Good morning. This is Mr. Miedema, and today I am going to be teaching you about exponential growth and decay. Exponential growth and decay starts with a percent change. Percent change is based on starting with 100% and either increasing or decreasing from there. So let's take a look at this example, and then I'll talk you through the formula that we're going to do. Lancaster High School has student elections every year. Lately, the school has seen a 10% decrease in voting from election to election. If 350 students voted this year, how many will be expected to vote 4 years from now? If necessary, round your answer to the nearest whole number. So after reading these problems, the first thing that you have to do is determine whether this is exponential growth or exponential decay. So when I look back through this problem, it says the school has seen a 10% decrease in voting. Decrease in voting means that this is exponential decay. The number of voters from year to year is decreasing. So the formula that I want to use is exponential decay. So let me write this formula for you, and then I'll talk about what each of the four variables means. So for exponential decay, the formula is y equals a parentheses 1 minus r raised to the x. Now, there's four variables here. There's x and y, which we've been using, and then there's also a and r. So let me explain what these four variables mean. In an exponential growth or decay problem, a is your starting value. R stands for rate. But there's a little catch with the rate, that many times they'll give you the rate in the word problem as a percentage, but you have to then change that percentage to a decimal. When we do the problem, I'll review how to change a percentage to a decimal. X stands for some interval of time. Could be seconds, days, years, any kind of interval of time. And finally, Y, that stands for your total. It could be total number of students, amount of dollars in an account. Okay, it's the total amount. So let's go back through this problem and determine where our numbers go. Lancaster High School has student elections every year. Lately, the school has seen a 10% decrease in voting. 10% represents the rate. We need to change that rate from a percentage to a decimal. The way that you change a percentage to a decimal is that you divide by 100. So 10 divided by 100 will give me 0.1. 10% as a decimal is just 0.1. So I know that for R is going to be 0.1. It says if 350 students voted last year, well, that was the starting amount or the starting value. That goes in for A. How many will be expected to vote 4 years from now? So how many, meaning how many students, I'm solving for Y, carrying down my 1 minus. And for X, it says 4 years from now. So I substitute in 4. If you look at the right side of this equation, it's all numbers. If I want to, I could simplify what's in the parentheses. 1 minus 0.1 is 0.9, all raised to the fourth power. And now I could just enter in exactly how it appears on my calculator. 350 parentheses 0.9 raised to the fourth power. That's an exponent. I get 229.635. So it says, if necessary, round your answer to the nearest whole number. Well, we're talking about the number of students. So we do want to round this to the nearest whole number. 229.635 is approximately 230 students. Okay, I'm going to go ahead and type in my answer. Just have to clear the writing first. We had 230 students. Okay, let's take a look at another problem. A newly launched clothing line is rapidly increasing in popularity. Every month, 20% more items of clothing are sold. If 22,000 items were sold this month, how many will be sold 4 months from now? If necessary, round your answer to the nearest whole number. Okay, taking a look at this problem. The first thing that we have to do is determine whether we have exponential growth or exponential decay. It says every month 20% more items. More items means that it's growing. So we need exponential growth. So the formula for exponential growth is very similar to the formula for exponential decay. The only difference is that instead of 1 minus r in parentheses, it becomes 1 plus r in parentheses. Okay, now we're going to go through and figure out where the information goes. Every month, 20% more. 20% is my rate. But again, I have to change my rate to a decimal. The way to change a percentage to a decimal is to divide by 100. 20 divided by 100 is 0.2. It says, if 22,000 items were sold this month, well, 22,000 items is the starting value or the starting amount. So I know that 0.2 goes in for R. I know that the starting amount, A, is 22,000. It says how many will be sold 4 months from now, meaning that I'm solving for Y. I'm going to carry down the 1 plus. And it says 4 months. That's my time interval. That goes in for X. Again, if you wanted to, you could go right to your calculator. Sometimes people like to simplify what's in the parentheses first. 1 plus 0.2 is 1.2 raised to the fourth. Now I'm going to go ahead and type it into my calculator exactly as it appears. 22,000 parentheses 1.2 raised to the fourth power. I get 45,619.2. It says, if necessary, round your answer to the nearest whole number. So 0.2, the 2 is going to tell the 9 to just stay the same. So I get 45,619. Okay, I'm going to go ahead and clear my writing and submit my answer. 45,619. 45,619. All right, let's take a look at another problem. Avery has $70 in a savings account. The interest rate is 5% compounded annually. To the nearest cent, how much interest will she earn in 2 years? So if you put money into a bank and you don't touch it, the amount of money will grow over the years. This is an example of exponential growth. So I'm going to use my formula again for exponential growth. Y equals A times 1 plus R raised to the X. Avery has $70 in a savings account. That $70 represents her starting amount, which is A. The interest rate is 5%. Again, that 5% has to be written as a decimal. Divide 5 divided by 100 to figure out that 5% is 0.05 as a decimal. To the nearest cent, how much interest will she earn in 2 years? So 2 is my time interval. I'm solving for y. If you want to simplify what's in the parentheses, 70 times 1 plus 0.05 is 1.05 raised to the second power. And now we could go ahead and use our calculator. 70 parentheses 1.05 all raised to the second power. I get 77.175, which rounded to the nearest cent is $77.18. Now you do have to be careful on this problem. It didn't say how much money will be in her account after 2 years. It says how much interest will she earn. So if she has $77.18 in her account, but she started with $70 in her account, we have to subtract those two values to determine how much interest she earned. She actually earned $7.18. I'm going to go ahead and clear my writing and enter in my answer. Avery earned $7.18. Okay, I'm going to go ahead and do one more problem. It says Roger has $500 in a savings account. The interest rate is 13%. To the nearest cent, how much will he have in 1 year? Well, again, if you're earning money, that's exponential growth. So we're going to use the formula y equals A times 1 plus R raised to the X. He has $500 in an account. The interest rate is 13%. 13 divided by 100 is 0.13. To the nearest cent, how much will he have in 1 year? So X is my time interval. And I could go ahead and simplify. If you want to simplify what's in parentheses first, and now you could use your calculator. 500 parentheses 1.13 raised to the first power. You get $565. Now just be careful. This problem says how much will he have in 1 year? So he will have $565. The last problem only asked you how much interest will he have earned.